So you're going to be watching this video looking for and listening to the landscapes that are created by glaciers. And then what we're going to do is I have some more pictures, the ones that New York State emphasizes for the regions. And then here on page 8, when we're all done, we're going to pull out all the major bullet points from the video, from the pictures, and talk about the things that New York State makes you know. And if you notice here on page 8, one box is for a sketch and another box is for the main ideas. I don't normally make you draw things. I'm a horrible person I can't by any means grade your drawings. I can't do drawings. But this chapter, it's all about what the area looks like. And we're going to draw some of the important things you're going to need to be able to recognize in a picture to say, oh, a glacier did that. So again, we're going to watch this 2.5-minute video and then watch some pictures, look at some pictures, talk about them, take some notes. So there's no notes now. So that's, I guess, what I'm getting at. All right, here is the video.
How do glaciers shape the landscape? Glaciers are frozen rivers of ice which have immense power. Glaciers are so powerful, they can carve huge chunks out of mountains as they flow downhill. This makes them one of the most powerful natural tools on our planet. Glaciers are sometimes called nature's bulldozer. Just like a bulldozer, glaciers shape the land in 3 ways. Firstly, glaciers pick up material. We call this erosion. Water flowing along the bottom of the glacier seeps down into the rock below. When it freezes, it opens up the cracks in the rock. This is known as freeze-thaw weathering. Then, as the glacier flows downhill, pieces of rock come loose and the glacier pulls them along with it. We call this plucking. Ouch.
Okay, actually, so I want to stop it here and ask you a question about what's going on here. So this glacier is picking up these giant rocks. Now, I don't know if you can tell how big these rocks are. These rocks can be as small as a piece of sand or as big as a car. Just like a bulldozer, glaciers pick up whatever the heck is in their way. So this is a rock as big as a car, and it's being pushed along the solid rock underneath. So there is some solid rock. What do you think that rock is doing to what the bedrock underneath it? So this solid rock underneath, what do you think this boulder is doing along the way? It is scraping the ground. I need you to keep that in mind. This video did not include that in the description, but it is something New York State really makes sure you know, is that these rocks that are getting picked up, as they're being pushed along the ground, they will scratch up the ground underneath them. So kind of think about that as the video continues.
These rocks and stones scrape along the glacier bed like sandpaper, taking more rocks and stones along for the ride.
But they don't.
This is called abrasion.
The ground as well.
Secondly, the glacier transports this eroded material as it flows downhill. Some of it is hidden inside or at the base of the glacier where it can't be seen, but sometimes it is transported on the top of the glacier. This is why glaciers often look dirty. As the glacier flows down a mountain, it gets warmer and starts to melt. Just like a snowman, anything which cannot melt is left behind. As the glacier melts, the rocks and stones fall to the ground. We call this deposition. By now, this material is a tasty mixture of rocks, stones, sand and clay, known as glacial till. The melted ice turns into meltwater and flows downhill to join a river or lake. Today, glaciers only exist in the coldest parts of our planet. But during the last ice age, glaciers existed in the UK too. Although the ice has melted, they have left behind.
Again.
Today, glaciers only exist in the coldest parts of our planet. But during the last ice...
Okay, this picture here is a perfect example of what the landscape is going to look like after a glacier's gone through. What does this look like to you? It's a valley. So hopefully you recognize that this is a valley. Now this valley has a particular shape that was caused by that bulldozer basically plowing through this area. Would you be able to describe that shape? Now, is it a V or a U? That's a good, I agree with that. What would you call that? Why not a V? V's have points at the bottom. This is a U. Just like that bulldozer. What shape is the front of a bulldozer typically? It's a square or rectangle shape. And a square or a rectangle shape, if you had to say that was a V or a U, what shape is that? A V or a U. Again, that's a U because it doesn't come to a point at the bottom. A glacier and a bulldozer, if they just plow through a pile of dirt, are going to leave this U-shaped valley behind. That is one of the number one things the Regents will ask you about on the Regents is what shaped valley does a glacier create when it travels through the area? They always create U-shaped valleys. They might even show you a picture just like this one that's up on the board. And you do have to distinguish between a U and a V. Remember, V's have points. This is definitely like a soft curve like the bottom of a U. Okay, keep going.
Ice Age, glaciers existed in the UK too. Although the ice has melted, they have left behind some awesome scenery. As our planet warms up, many of our amazing glaciers are melting fast. So grab your walking boots and head to your nearest glacier while there's still time to see nature's bulldozer in action.
All right, good enough. Love it. So a few more things. So that showed you just a few of the things that glaciers can do. I want to show you the rest of the pictures of what a glacier can do. A boulder is actually legit one of them. So, oops. So we started with they look like bulldozers, or they act like bulldozers. Now they did mention, go ahead, I can talk louder than that. They did mention glacial till. Did you guys happen to catch what the till was? It's not like the till, like you're tilling up the field. Is that what you were getting at? Is that what you were thinking too? Yeah, that's not in the end. The till is all the junk and debris that was in that glacier as it was moving. They kind of talked about it as the snowman. So a glacier is going to pick up, literally just like a bulldozer can, anything that's in its way. It's going to pick up little rocks, big rocks, medium-sized rocks, a house if there was one there. It's going to pick up literally whatever's in its way and bulldoze it over. When that glacier melts, just like when the snowman melted, what's left behind? There is water, but also what did it say about the snowman? Anything that's in it is going to get left behind. So the eyes, the buttons, the scarf, the hat, the nose, all got left behind. It's going to be a mixture of whatever the heck it was, whatever the heck there was, is going to be left behind. So it's going to have those small rocks, the medium rocks, the giant rocks, all get left behind. And that's called glacial till. Here is an example of some glacial till.
Why is there a phone in that?
Okay, so why is there a phone? And first of all, let me tell you that appears to be, it is a phone. Trust me, that's a phone. I believe it legit looks like my very first phone. I did not take this picture, but that was probably my very first like style phone that I ever had. Doesn't even look like a phone to you guys. No, it was before flip phones too, but it looks like a little bit more like a wireless phone, a house phone. I agree. But anyway, it's there, I think, just for size reference. Because back when this picture was taken, everybody knew how big those were, which are honestly about the size of an iPhone as well. So it's just there for size reference. So speaking of sizes, what do you notice about all the rocks here? There's big ones. There's some small ones. There's some sticks. There's some sand. There's what? It's a mixture. I need you guys to understand that a glacier carries a mixture of sediments and then drops off a mixture of sediments. We'll take notes at the end, so you guys don't need to be writing that down yet. We'll get it all at once. But glaciers carry and drop off a mixture of sediments called glacial till. Oops, too fast. One thing that can happen is as a glacier is traveling down the mountain, it will clear a path and then drop off sediments as soon as it starts to melt. By the way, how do you think a glacier moves? Because does a glacier have feet? No. Does a glacier have wheels? No. So one thing it can do is melt down a mountain. So it's going to slide down the mountain. I think this is obvious to see that gravity will pull this glacier down a mountain. But what happened during that ice age when the whole country was covered in ice? How did it move then? It wasn't always down a good slope. How did glaciers move? First of all, do you even know what a glacier is? It's ice. How come it doesn't melt? Because there's too much of it and it stays cold. So really what happens is it just snows. So I'm using some Play-Doh to represent some snow. And it snows. In fact, just like now, how come we don't have any glaciers now? It's snowing. It's not cold. It's not cold, but it's cool enough. It's snowing. It's kind of like a snow pile. You guys know like those big snow piles that they have in Tops parking lots? You know how those last well into when it gets warmer? Takes them forever to melt. Because one thing is, once there's snow, it kind of keeps itself colder. So it does take it a while. Also, once it gets mixed with dirt, the sun's going to it's going to like create a little layer of ice, which will also keep it warmer. But anyway, how a glacier happens is it snows and then it doesn't melt. And then it snows some more and it doesn't melt. And so on and so forth until you get a giant glacier. Now this pile of snow, even you guys can probably experience it. Does the snow always stay fluffy? What's it do? It does get compacted. Compact. Hey, when I take this pile of Play-Doh and I compact it, what do I need to do to compact it? Squish it down. Watch what happens to this Play-Doh container when I push down the snow. What did the container just do? It moved a little bit. That's how glaciers move. Is the snow is heavy and gravity pushes it down and causes it to go and spread out. Now, the one thing that's not here is in real life, a glacier is already like on all the sides except for one. So it only has one direction to move. So that's how a glacier moves, is the weight of the snow squishes it down and pushes whatever is in its way out of the way. Once it stops growing and it finally warms up enough for it to start melting, it'll start dropping off its goodies. All its, what do they call it? A tasty mixture. So it'll drop all the stuff that it was carrying, and this is called a moraine. A moraine is a hill of glacial junk that forms where the glacier stopped. So this pile of dirt here is called a moraine. Glaciers can also do some damage to the mountains and the ground that they're flowing over. We saw that with the plucking in the video, how it's going to pick up chunks of rocks and leave behind others. And it can create a landscape that looks like this. These are called, those words, don't know how to pronounce most of them. Horns I get. So horns, you can see why they're called a horn. Do you need to know what these are? No, you just need to know that if you see those words, a glacier did that. So here's just some more pictures of those. Again, what do you see here? A valley, a U-shaped valley. Great glaciers always create U-shaped valleys. They also create these little hills called drumlins. A drumlin is a specific shaped hill. They say it looks like the back of a spoon. Genesee Road from North Collins to here, my drive to work all day, every day. Bunch of little hills. That's these. These are drumlins. They are little, weirdly shaped hills. If you dug inside these, you would find a bunch of mixed up size sediments. Again, drumlin. Looks like this helmet here. This helmet, it also, why do they have the blunt end and then it points out? It shows airflow. If you put it backwards, it wouldn't flow the same way. This helmet helps you figure out that the air is hitting here and going over. Just like these drumlins, it hits the direction of the glacial movement. You'll see the blunt end, and then it comes over the top. Drumlins always have that weird shape. Kettle lakes. What's a kettle? A pot. Okay, like a big pot that you might cook corn in. That's a kettle, so it's a really big pot. What is distinctive shape of a pot? What about the sides? It's a pretty, again, I basically drew one here. This is a pot versus a pan, like a frying pan. A pot has steep sides and it's a deep pot versus a pan has gentle sloping sides and it's not very deep. A kettle lake legit looks just like this. And a kettle lake happens when a chunk of ice, actually, do I have it in my next picture? Yep. We get a chunk of ice breaks off the glacier and it starts to sink into the ground that it's sitting on. And then it melts and you've got a lake with steep sides and no like coming in or going out water. That's a kettle lake. Again, caused by glaciers. You can see here, so we have a glacier coming down a mountain. And once it gets down to the bottom of the mountain where it's nice and warm, it starts to melt. And again, you can see that pile of whatever the heck it was carrying gets dropped off, and then the water just flows off like a river. You saw this picture at the beginning, said it's a boulder. Well, where the heck? How did a boulder, I don't know if you can see, this is the middle of New York. This is Central Park in New York City. Giant boulder in the middle of Central Park. Does it look normal? Here's a giant boulder in the middle of the woods. Does it look normal to have a giant boulder just sitting in a field? These are called erratics. Do you guys know that word? My husband used to get called when he was a trooper to erratic drivers all the time. That was his, like, one of the number one calls on the thruway. There's an erratic driver. What was he getting called to? A dangerous driver, a crazy driver. There's lots of reason people are erratic drivers. He used to get called to the same car every single Tuesday. It was a little old lady. She'd get called in. People literally thought she was dead behind the wheel driving. She literally could not see over the steering wheel. All you could see is this little gray fluff. And she'd get called in every single Tuesday because she was going like 20 miles an hour down the thruway. She was going to bingo on the reservation every single Tuesday. And unfortunately, he stopped getting calls for her. So we can always only assume like her license got removed or her car taken away or, well, she was old. But anyway, erratic drivers, drunk drivers, old drivers. Now that I'm driving with a teenage driver. You guys are all nuts. Crazy drivers. This is a crazy rock. Erratic means it doesn't belong. This rock doesn't belong here for multiple reasons. So this is probably one of those rocks that got picked up by the glacier, got plucked off, and carried somewhere else. I'll tell you that the ground underneath New York City is all sedimentary rocks. But this rock is a piece of granite, which is an igneous rock. Does an igneous rock belong just sitting on top of sedimentary rocks? So did it come from the rocks that are right there? This came from somewhere else. Where do you think it came from? Which way was the glacier moving, you think? It was moving south. It came from Canada, and this rock got pushed down into New York City. This again is proof that there was a glacier once in New York City because this giant igneous rock does not belong. It's erratic.
Is there any other ways that you get there?
Obviously, I mean, these are huge. You can see how big this is. So obviously a human could move it there. But it's if there was a volcano, for example, because it is igneous, there would be more igneous rocks underneath it. So it doesn't belong, like we know it didn't get there, like wind didn't push it there. Water's not moving a rock this big. The only thing strong enough to move a rock this big would be a legit bulldozer or a glacier. So finding these erratic rocks, these rocks that don't belong, is proof that a glacier must have been there. So here's just some more. We've got random giant rocks where they don't belong. We talked about the scratching a glacier will do. As it picks up those rocks and then starts to move around. Kind of like my husband always yelled at the kids when they would help him wash the car and they'd put the sponge down on the ground and then wash the car. What's the problem with that? Okay, there's probably now dirt and debris on the sponge and you're going to wash the truck with it. It's going to leave behind scratches. The same thing happens with the glacier. If there's a rock inside the glacier and it's moving on the ground, it's going to gouge out the ground. And these are called striations, scratches, or grooves. You can see, so that's a Swiss Army knife there. So you can kind of see the scratches in this rock. This is going to be more of a groove. It's a much bigger gouge. It shows which way the glacier is moving. So clearly it wasn't moving this way and carrying the rocks. It was moving one of these two directions, either up and down on this picture. And here's just some more examples of those scratches on rocks caused by glaciers. Here are the big ideas that you need for glaciers. So we're going to put these on page 8 underneath the box for glaciers. Glaciers move by the force of gravity. They pick up and move anything in their way, any size. When they drop off the sediments, they're going to be unsorted, meaning any size. And here are some of the vocab words that you need to know that go with glaciers. U-shaped valleys, striations, grooves, moraines, kettle lakes, drumlins. And then the last bullet there is that they have created almost our entire landscape in New York State. Either one. Yep. So like I was saying, the Regents doesn't make you know exactly what a moraine is or exactly what a kettle lake is, but you need to know that moraines, kettle lakes, and striations, they go with glacial erosion. So if you don't remember what a moraine is, that's okay, but you do have to remember that it goes with glaciers. Everybody get that? Okay, couple more things. What should we draw for the sketch of this? Let's start there. What's one really big thing about glaciers that we can draw? Simply. Avery's got it. Let's draw this. What is this? That's a U. Remember that they create U-shaped valleys. Yeah, honestly, as long as you have them in one or the other box, I don't care which one goes where. I can guarantee you they are going to ask you something about valleys this year, U-shaped or V-shaped. We're going to learn what creates a V-shaped valley. All right, we just have two more things. We have plenty of time to get it in there. On the top of the next page, glaciers have also created the Finger Lakes. You guys heard of the Finger Lakes in New York State? They're over by like Rochester area, a little bit south of Rochester. Can you see why they're called the Finger Lakes? Looks like somebody went through with their fingers and scratched them, or they look like fingers, depending on which way you want to think of it. Finger Lakes were caused when there was already a valley there, a V-shaped valley. By the way, V-shaped valleys are created by rivers. As you can see here, this V-shaped valley. What happened is the glacier filled in that valley, and we already know what ice can do. It's going to pop out and carve that valley deeper, creating that U-shaped valley. And it just happened to do it in 5 existing river valleys. So the Finger Lakes, let's see. What do we need? Let's get this first bullet. They were pre-existing stream valleys that were modified by a glacier. So we'll keep that like, whoa, where'd that go? Sorry. So they were pre-existing river valleys modified by a glacier. And then we'll get the last bullet in there. The directions of the lakes show the movement of the water, movement of the glacier. We'll just leave it like that. You are going to have homework. It's going to be the rest of page 9, 10, and 11. It's 14 questions. Not an overload. It is 14 questions. 9 through 11. It's all about glaciers. So if you need to look back at the stuff we just wrote, you can. All ready? Perfect.